So we're going to talk about complex numbers. We're just going to talk about adding, subtracting, and multiplying complex numbers today. A complex numbers have a real part and an imaginary part. Sometimes the real part is 0, but it's written as a plus bi. I want you to look at that, a plus bi right here. So the real part is always written first. The imaginary part is always written second. So sometimes I have to rewrite my answer that way. And I is the imaginary number. So I means the square root of -1. And I squared. So if I have I equals the square root of -1, right? If I square one side, I have to square the other side. So I squared. What happens to a square root when I square it? It cancels out, right? So that means that the square root goes away and then I squared just equals -1. That's why that I squared equals -1, okay? So those are two relationships that we're going to use a lot today right here. And then we just have the number system on here and where complex and imaginary numbers fit in the number system. So we have whole numbers down here that we start with, and then integers and rational numbers and irrational numbers. Those are all real numbers. And then all real numbers are complex numbers. And then inside of complex numbers, we have these imaginary numbers. And imaginary numbers are just all by themselves, okay? So although they are complex numbers. And then we talk about graphing. This is how we graph imaginary numbers. We have a real axis and an imaginary axis, and it's just like graphing like -3, 4. Only I would write it -3 plus 4i. I would go -3 on the real axis and then up 4 on the imaginary axis, and it would be there, -3 plus 4i. So we just have a plus or minus sign in there. It's pretty easy. Okay, so the imaginary number is my y and the real number is my x. Okay, in case you ever see that on like a placement test. Since you guys are juniors this year, you may have seen it on the ACT, but next year, if you're going to place for concurrent, you may see it on that. And then as a senior or when you're going into college, you may see this type of stuff on a placement test. Okay, so there's operations with, I'm going to make this big so you guys can see it and I'll read it from the screen. Operations with complex numbers. To add complex numbers, we add the real part to the real part and the imaginary part to the imaginary part. It's just like adding like terms. So we just add like terms basically. And same with subtracting. We're subtracting the real part from the real part and the imaginary part from the imaginary part, okay? And then multiply, we just multiply, use the FOIL method and combine like terms. So we just multiply like we normally know how to multiply. And then, so this is the part right here that is not in your notes already. So this is a new part. These 6 problems right here are not on your notes already. So if you can just find a little area to write them in, that would be awesome. And we're going to talk about them. So it says we want to simplify these and we want to remember 2 things. When I'm doing this, I want to remember that I equals the square root of -1 and I squared equals -1. So for these problems, I can have one of 4 answers and that's it, okay? I can have 1, -1, I, or -I. That's what my answer is going to be. One of those 4 answers, that's it. Okay, that's the only answer I can have. And so what I want to do actually is I know that I squared equals -1, right? Is everyone okay with that? Yes, dear. Do you have a charger? No. So, okay, so what I want to do is I want to make sets of I squared because I know every I squared equals -1. Is everyone okay with that? Makes sense, right? I want to put it into terms of something I already know, which I know is I squared is -1. So I have I cubed, so I can rewrite that as I times I squared, right? Isn't that I cubed? I just unmultiplied it, okay? So then this becomes I times negative 1 because I squared equals negative 1. So I can substitute, right? I can take I squared out and put negative 1 in. So I just substituted there. And then if I multiply this out, it becomes negative I. Done. This isn't in your packet, Emma.
Okay.
So these six problems aren't in there.
I was so confused. I was like, wait.
Yeah. Yeah, no, these 6 problems aren't in there. So you just have to write them down somewhere else. You could probably fit them in right up here because they don't take that much room up. But unless you want to get a separate piece of paper and staple it in there too. Okay, so now if I go to number 2, I notice my exponent's getting bigger, right? Now I have I to the 12th, and I still want to put it in terms of I squared because that's what I know. So this time I'm going to rewrite this as I squared to the, what's going to make that a 12 instead of a 2? I squared to the what power? 2 times 3 is 12? 2 times 4 is 12? There we go. 6, right? So 2 times 6 is 12. I just multiplied it, I guess. I don't know how I want to say it. I did the property backwards, right? So I have my exponent properties. I'm undoing my exponent properties. So now I know what I squared is. I squared is negative 1. So I have negative 1 to the 6th power. So it's negative 1 to the 6th power. Now I can put it in my calculator if I really want to. But I hope that you know negative 1 times 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 negative 1. You can think about it in your head. But if I have an even number of negatives, is it going to be positive or negative? That's my question. If I have an even number of negatives, is my answer going to be negative or positive? It's going to be positive, right. If I have an odd number of negatives, is my answer going to be negative or positive? Negative. So I have an even number of negatives, so I know my answer is going to be positive. So I have 1 to the 6th power, which is what? Yeah, 1 times 1 times 1, which is? 1. Yeah, 1 to the 6th power. 1 to any power is just 1. So this answer is positive 1. That's why I want to put it in terms of I squared, right? Because we know what 1 to any power is 1. And then I just have to determine if it's negative or positive. Okay, and then number 3. Oh, look at this one. 137th. Okay, so in order to get it into I squared, I need an even number, right? So I'm going to rewrite this as I times I to the 136th power. Okay. So then I want to write this as I squared to what? 2 times what is 136? I don't know. I'm going to get out my calculator. 68. How did I find that? I took 136 and divided by 2. Yeah, 136 divided by 2, right? So then what's I squared? I squared is negative 1, right? So I've got I times negative 1 to the 68th power. So what's negative 1 to the 68th power? Negative 1 or positive 1? Positive 1. So this becomes I. Done. Does that make sense? Okay, I want you guys to try and attempt these 3 problems. Go over these. Let me zoom in here. And so number 1, number A, I wrote as I squared to the 120th. So that's negative 1 to the 120th. And it's an even number, so that means it's just going to be 1. Okay. And then, let's see, I wrote as I squared to the 81st power. So that's negative 1 to the 81st power. And since it's an odd power, it's going to be negative 1. And then C is a little more involved because it's an odd exponent already. So I've got I times I to the 314th, which becomes I times I squared to the 157th. So that's I times -1 to 157th, or I times -1, which is negative I. Question? Are we okay with that? Daniel? No, which part?
I'll get
All of it? Or just part of it?
after the second part.
After this part?
Yeah.
So we know that I squared equals -1, right? So I took the -1 out, I squared out and put -1. Okay? So I substitute, right? You know substitution, right? Okay? So, and then -1 to the 157th, it's just 1 to any power is 1, right? So then I have to decide if it's a -1 or a +1, and how I decide is if this exponent is positive, right? If I have an even amount of negatives, my answer is positive. If I have an odd number of negatives, my answer is negative, yeah. So that means I have an odd exponent, so I'm going to have -1, and then I just multiply it together. Is that okay?
Yeah.
Okay. All right, guys. Now I think we're back to your packet. Okay? So, and we're gonna work through these. It says perform the indicated operations and write the answer in standard form. Standard form for this, for a complex number, is A plus BI. Notice the imaginary number is last and my real number is first, so I have to write it that way. Okay, so the first one, what am I doing on the first one? The first one I'm adding. Okay, so I'm going to add the two together, so I'm just going to add my like terms. So my first like terms are the 3 and the 4, and the second one's the 5i and the -3i. So I get 3 plus 4 is 7, and 5i plus a -3i is 2i. That's it, done. So all I'm doing is adding my like terms together. Okay, that was not for me. So number 2, go ahead.
I was going to ask, for this, can you multiply, not like terms? So like the...
Yes, yeah, we're going to do this on the next one. So the next one is multiplication, right? And I'm going to multiply number 2 using the box method, because sometimes when I'm using the i's, I like to have that together. It's just me, just my personal choice. You can FOIL it out if you want. That is perfectly great. So I have 5 plus 7i, or 7 plus 5i. So I'm going to multiply this together, right? So 5 times 7 is 35. And 5 plus 5i is 25i. And 7 times 7i is 49i. And 5i times 7i is 35i squared. Okay, what is I squared though? -1. So that means this becomes -35. Okay? So my answer is going to be 35 minus 35. That's 0. Yeah, 49 plus 49. That's 24. That's 50. 74i, I think. I did that in my head, so I don't know if that's right. I'm not a very good adder in my head. Okay. Sorry, my mom just texted me. So 74i is my answer. This next one, it looks like I'm only combining like terms again. Interesting question. Okay, so my like terms on the last one are just -6i plus 7i. So it looks like I'm going to have 11 plus I. And that's it. Okay. Does anybody have any questions on it so far? Not too bad. It's just like with a variable, right? I mean, with an x, only if I have x squared, it changes to a what? A -1. I squared equals negative 1, right? So we're going to go ahead and have you, there's 6 problems. I'm going to try and show these up here so people can still see them. At least most of the people that put answers in the chat got them right. So let's get this done. So I'm going to add my like terms. So 13 minus 7 is, what is there, 6. Yeah, that's it. And then negative 5 minus a negative 11 is 6 also. So that's 6 plus 6i. And then we've got, we're also subtracting here. So I'm distributing my negative. So 17 plus a minus 5 would be 22, yeah, minus 6i. And then we've got, then we're going to multiply here. So I'm going to distribute also. So 3i plus 7 is 21i. And 3i plus 2i is 6i squared. So this becomes, I squared is negative 1. So that's negative 6 plus 21i. Okay, and then we're on D. Oh, sorry. Negative 6 plus 21i. Are you okay with that one? Okay. So D is, again, I'm just going to use the little box here. And I've got 5 minus and 3 plus 3i. So 15 minus 3i, 15i, and negative 3i squared, which becomes positive 3. So my answer should be 18 plus 12i. Okay. And then, any questions on that one?
Forgot the one.
Uh-oh, you forgot the negative one?
No, I forgot to add the 1 on 18.
Oh.
It was 8 plus.
Oh. I understand that issue also.
I don't know, it's like my brain just doesn't function the way I want it to.
Don't talk about that, let me tell you. 4 times negative 2 is negative 8. And then negative 16i and negative 4i. And then this is negative 8i squared, which becomes positive 8. So that means 8 minus 8 is 0. And then, so this is going to equal negative 20i. Beautiful. Any questions on that one? Okay. And then we've got 7 and 4i and negative 3 and negative I. So I've got negative 21, negative 7i, negative 12i, and negative 4i squared, which becomes positive 4. So my answer is going to be, let's see, what is my answer going to be? Negative 17 minus 19i. Of course you can, Jess. Not a problem. Okay, any questions on that? No? That's it. That's the end of the lesson today. It's a short, nice short one. You guys have some Delta math, so you've got about 40-ish minutes to work on your Delta math, and it's, I think, like 12 problems.
Can I get the bathroom?
Yes.